this is just the basic time I've spent on MATLAB. This is not ANN. We did not start at ANN. This is just like we have Excel sheet, how to import the data from Excel sheet, and how to define what could be my input and what could be my output. That one we did. Now we are going to work with ANN. So everyone go to their app section, applications, and when you scroll down the application sections, you can see some favorites here. Machine learning toolboxes are here. So these different toolbox has a different application or different use. Now we are going to work on neural net fitting. So select your neural net fitting. Can you see my this neural net fitting toolbox? NF toolbox here in your screens. Can you able to see that? No? Just a second. I think I will share again. Can you able to see now? My There is NF toolbox. Welcome to neural net. Yes, okay, that's good. So this is the main. This is a magic box. MATLAB has done all the coding for this. It has given you to develop ANN modeling using this toolbox. No need to write any code. Not a single line of code is required to develop ANN model. You can use this toolbox. So now what we have to do is, after you open this toolbox, just click on the next. So in next, now the first step is to define the toolbox. What is the input variables and what is your output variables. So select input. In here, what is the input variable is in. So just select your input variable in and the output variable OP out. You can give any names. This is just names. I'm waiting for a few seconds to see whether you guys come here until here. Select input variable and select output variables. Need to download the neural network. I think, but Dr. Ashraf has already asked everyone to download this. I told him yesterday. Can you do it, Madam Nurain, fast? I think it is not much more. Um, Maybe 10 minutes. Everybody else is having this toolbox, because if you don't have this toolbox, we cannot do the ANN model. Anybody else is not having this toolbox? Or everybody got this one? Can you just confirm through chat yes or no, so that I can know? Okay, yes, good. So you have toolbox and you have done until the select data. That's wonderful. Okay, until Madam Noorine does download her app, what I am going to show you is in my paper. I'm going. Can you see my paper now? In this paper, in the methodology section, whenever you write it ANN paper, you have to optimize your ANN model. There are different categories of optimization. By changing the hidden neurons, by changing the different input rates and the different percentage of the training data set. So here in this paper, we have optimized the ANN toolbox by changing the hidden neurons. So what we did, we made the hidden neurons as 5, 10, 15, and then we have reported if you take the hidden neuron as 5, we will get mean square error for the ANN test as 0.9854. When we make it 10, it is like this, and when we make it 15, it is like here. So for different ANN models, you can do the different hidden neurons. We have kept the ANN algorithm same. Some people, what they do is they first make the hidden neurons for each algorithm, then they optimize the best, decide which is the best algorithm at best hidden neurons. So these kind of tables you have to make in your methodology section whenever you're writing a paper. And something like this, there is another table you can make on this thing. We just put it as a picture. Okay, so now I believe majority of you has done the input and output toolbox. Madam Nurain, I will proceed forward, and then if you have any problem, I will ask Dr. Ashraf, or I will explain you again the same process. Okay, so now once you select your what is your input here and what is the output of your NN algorithm, just click on next. Next here, we are going to define the MATLAB toolbox. The default here MATLAB takes is 70% for training, because as more data required for training, the better the ANN model will be. So 70% for training, 15% data will be taken. We have total 856 samples. So in that 856 samples, the 600 samples will be used for training the ANN model. 128 samples will be used for uh, validation, and another 128 will be used for testing. In our ANN workshop last few days back, we have only training and testing. In MATLAB, we have training, validation, testing. In ANN, we have to define for validation. Here, no need to define. By default, it will take 70% for training, validation, testing. In some cases, you don't have sufficient data. Maybe you have only 100 data points. So you don't want your data points to miss, like 15 means 30 data points will go for validation testing, and the training will be only 70. So in that case, you can reduce your validation data points as 10 and testing as 10. So the training will be done for 80% of the data points, validation will be done for 10%, and testing will be done for 10%. This 80 percentage, it will not take first 80%. It will divide the data points randomly and take the 80 percentage of the value. Maybe it may have, randomly it will be selected. So you don't have the bias. Maybe at the end of the experiment, last 10 data points are, very good, so all those will go for testing, means your ANN model will look very beautiful. So what MATLAB does is, all the data points you have given in the input, here 856 samples, it will divide them randomly and give 80% for training, 10% for validation, 10% for testing. But we have good values here, 856 samples, so we will keep 15% for validation, 15% for testing. You have to reduce this in the case where you have less samples. But here we have 856, so we are proceeding with that. Okay, once you select this part, okay, just select next. Can you, is everybody got till network architecture? Can you just
You said 70%, is it, or 80%?
70%? Just make, just keep validation 15, testing 15, and the training will be 70 automatically. After you just make this 15, 15, click on next. Here is the next button. You will get the network architecture. Uh, just give me 2 minutes. I'll be back. Okay, now I'm back. Okay, I believe that everyone is at network architecture. So this is hidden neurons. This layer you can see in this toolbox. This is hidden layer. You can change the hidden neurons more if you want to increase the efficiency, but there is no fixed method to calculate number of hidden neurons for each data set. So you have to do the optimization of hidden neurons. So usually we will start at 5, and what happens is 5, if you do 5 hidden neurons, develop the model, maybe R square, maybe 0.88. And when you do 15 hidden neurons, R square may be 1. So you will say, okay, 15 is what the optimum hidden neuron for me. So you have to change from usually from 5 to 20 or 25 based on the number of input data variables. Okay, once you select your hidden neurons, I'm selecting here 5. So every one of you just select 5 hidden neurons, then select next. When you select next, it will say here about creating network. Okay, you got this train network window in your algorithm. Once you get the train network window, ANN will give you the 3 training algorithms. These algorithms, every algorithm has a different mathematical perspective behind uh, formulation to calculate weights and the importance of each input variable. So you can take different algorithms and then see which algorithm is best suited for you. So you have to make it table here again. The first table in your methodology section will be we work with the Levenberg market algorithm at this particular hidden neurons, and we got this R square. We work with how to change the algorithm. There are 3 algorithms here: Levenberg market and Bayesian regularization, scale conjugate gradient. So these are 3 different algorithms and 3 different mathematical formulation for 3 different algorithms. So let us say now we choose Levenberg market algorithm. First section, first section of the uh, model, we choose Levenberg market algorithm. After you choose the algorithm, select for train. Once you click the train button, this window will come. Okay, so here you can see here hidden we have choose 5, 8 is our input, 1 is our output. Okay, you can see train network here in the first. Okay, the random data division was done by random method, and the training is done using Levenberg market algorithm. Performance is measured by mean square error. Calculation is mix. Here it will give you the different. This is the gradient performance of the algorithm, time took for the training, how many iterations it made to give the best optimizations, 32 iterations, and the performance if you want to see for your ANN algorithm which you develop here. If you click on the plots here in the down section, just I click on the performance. So it is opening a performance window. Can you see this performance window here, everybody? So this is the performance of this ANN algorithm. So the mean square error is very high. You can see here is 240,343.22. Best validation performance we got at this very high mean square error, and epoch is 26. We have okay, this is the performance. If you want to see the regression of each section, just click on the regression plot. It will give you how is the data points. This is the regression line fit, you know, and this is for overall ANN algorithm. see the R square here is very good, 0.9935, but mean square error is very high. So we cannot go for now because Dr. Ashraf was keen for me to make a workshop so that you are writing a paper. So we are writing a paper. Let us assume that we are writing a paper. Okay. Now everyone kindly open a Word, Microsoft Word, a Word document. Something like this. So basically, we will proceed as if we are writing a paper. So the first thing is make a table here. Uh, I will explain you about the different aspect of the ANN, but just we are writing training algorithm. Just keep algo, and then MSE, R square, and neurons. So the first one is ML, Margaret Lernberg. So we will keep the training algorithm as ML. Here, what was the MSC value which we got here? 240343. 240343. I'm forgetting about the point. So, but R square is 0.99. The R square here, you can see in this window is 0.9935. So the R square is 0.9935. And what was the neurons we have selected for this model? It was 5. Okay. But you, okay,
Kau,
now uh,
Azad.
I will show you how to save this picture. Just go to the edit section in this picture. When this picture opens, go to the edit section, copy figure.
Buka lampu Azad. Buka.
You can
Batu dah.
copy that figure, MATLAB figure, paste
Buat
it here.
babai pula segmen tengok tu.
Okay. Same for the regression picture. Just go to the edit section, copy figure, it will be copied. Come to your Word and paste here. So it will give you the about the regression for the ANN model. So now we come back to this. We have to learn a important aspect of this. Now we trained, we got what is the MSE, what is the R square. Now I want to, because I told you initially our purpose is to predict. So I will show you how to use this, what we develop now. Just click here, just click next. So you'll get the evaluate network. We don't have the data for cross evaluation validation. If you have the data, you can give it here, input and the output. And then after that, go for next. Okay, you will get deploy solution. Deploy solution is your ANN model is ready. Now you have to just save it so that you can use the ANN model for your future use. So just select the second function, code generation. We want to generate a code for this development. So it will develop automatically, it will generate a code and it will show in your editor file here. Function YL my neural network X1. Okay. So now I want to save, I have to save this code to utilize for my future prediction. Any prediction I want to make. So how to save this code? Same, click on run. But one thing you can observe here is the file name is the default. It will giving my neural network function. You should not change this file name. Why you should not change? Previously I told you can keep any file name. Why I'm telling you not to change this file name is because this particular file is the function file. You can see here untitled 3 is the function file. Whenever whatever you write in the function file, the file name should be same. Here we write as my neural network function, so the file name should be my neural network function. Just click on the save. So I'm just keeping here. I'm making a another folder, ML 5 neurons. So I'm keeping my file here, save. When you save a file in another folder, it will ask you to change folder. I changed it. So this file is run now, but it says not enough input arguments. We develop the NN model, we save the NN model, but it is not working. It is giving you error.
Tak nampak. Akak buka lampu tu kat
So
di
because the
tempat
purpose of
quality.
this NN model is to predict. So we did not give them what to predict. We have to tell now the same ANN model what to predict. Okay, the prediction one. Okay, in the prediction one,
Sorry, Dr. Irfan. Can you pause
yes.
for a while? I mean, I'm struggling to save the file name just now.
Okay. I'm waiting. You guys save the file name and then
Can you repeat from the do not use the same name as the
okay. I will go to toolbox. See, when you click on the matrix generation, this will be open. Function y my neural network. So when you click on the run, it will give you a file name here by default. My neural network function. Keep this file name same. Don't change this file name because this is a function file. So just keep this file name here. Don't do anything. Just click. So just save it. When you save, you will get the error.
how do we save
Just once you open this file, run. When you run, it will ask you to save.
oh, okay,
One,
okay. Fine.
yeah.
So just choose the same file name, is it? My neural network function.
Yes, just choose the same file name and keep it in a different folder. Now, because we don't want to get confused which folder has, because every file name will have the same name, my neural network function. So we have to identify ourselves which file we are utilizing. So here I made another folder, ML5 neuron. It is ML is for the algorithm Melvenberg learn kit, and the 5 neuron is the number of neurons. So I'm saving here. So I should know where I have kept. Okay, so clear till here, everyone? I'm going to chat just to see. Okay, okay. You save the regression file. After the regression file, just yeah, this is here is the where you got the regression and all. Just click on the next, then again next. Go to generation, MATLAB generation, MATLAB code generation. Click here, MATLAB matrix only function. So this is the code generation. We generated a code. Once your code shows in the editor file, click on the run, keep the same file and run it.
I got error.
Yes, you will get the error.
No,
You got,
I got this error. Pause on errors. Pause on warning. Pause on. I don't know what's happening.
you got not enough input arguments.
Yeah, but then when I change the folder, I got this.
Yeah, it will ask you to change folder. Did you change the folder?
Uh, I don't know whether I did it correct or not. So
Okay, no problem. Now just close this one. Go back to your ANN model here. Click
okay.
again, generation function. It will open again. Make a file again for you. Run it. Save it. Change the folder. It you will get the same thing. You can do it.
Mhm.
Sorry, can you go back to the neural hidden network there?
Yes.
The one that you specify neural hidden network 5, and then I went to the next one, but the next one it didn't allow me to go to the next one. Yeah.
Here. Can you see now? What was the error? Why it is not allowing you to go to next?
No. After that, next. I click on next.
Yes.
Okay, what should I choose then?
Okay, here if you click next, here the algorithm you have taken is Levenberg market. You just click train here, click train,
Mm,
because I already trained, so it is asking me to retrain. I don't want to retrain, just train.
okay. I got it. Thanks.
Yeah, once you click train, after that go for next, select matrix generation function.
Okay, got it.
Okay, is everyone got till here? I will tell you what is the difference of retrain, everything. I just want you to go by step. That's what we are going to do for another 1.5 hours. Retrain, change algorithms.
Sorry. So the purpose of saving the docx file in a different folder
Yes,
instead of on the same on the desktop is to
purpose is purpose is we are going to have very big number of my neural network function files, but we cannot keep change the file name, so when we go like we keep on saving in the same folder, we cannot keep two files, because the same name we cannot keep two files, that's why it will ask you to change the name. We cannot change the name. That's why we are making different folders to identify ourselves. Why we did this, save this file, after you generate the code, it is now not necessary to make another ANN model and do everything again. You have this file saved in your computer. Whenever you want, just open this file, click run this file, give the different input, you will get the output. That's the purpose of this file. This is a trained ANN model file. Now that's what I am going to show you now. Is everyone? I'm believing that everyone got now till this function. They got this file, they save this file in a different folder. So now I'm going to tell you how to utilize that file to predict for different input values. Is everyone got till then? So that I can proceed to the next step. Okay. So once we got this thing, what we are going to do is we are going to give a hypothetical number. For example, now we say that there are first input variable is confirmed cases, right? Now we have to see the input variables. The first input variable is confirmed cases. Let us assume the confirmed cases is 20,000. And in the second row, the age 65% population is in that country is 25% of the population is having more than age 65%. And that country has very high percentage of smoking. This is hypothetical or futuristic thing. We are just predicting. If that country has 50% smoking rate, and then the percentage of high blood pressure population is, let us say 25%. Daily asthma cases, here it's a normalized one, so 0.0078 daily asthma cases. Daily cardio cases is again normalized 0.3, let us say 0.35 is the daily cardio cases. Just we are giving one hypothetical case. And let us say the population is 35 million. 35 million is the population of that country. And then physicians per 1,000 people is very low. Only 2 physicians are there per 1,000 people. So this is my hypothetical case. I want to know if these are the things happening. 2,000 confirmed cases, 25% of the population is more than 65 years of age, 50% population smokes, and 25% population has the high blood pressure problem. Asthma case is 0.07, cardio case is 0.35. Population of that country is 35 million, and there are only 2 doctors per 1,000 patients. So now I want to calculate what could be the death. So once I do this, click on the run so that I want add to path. So that I want this prediction 1 is shown here in workspace. Can you see that prediction 1 is shown in the workspace? Okay. After this, I want to use this ANN toolbox, ANN network, ANN model to give me what could be the death rate. So come to the command window, just select up row. There are up and down rows in your laptop or PC. Just click on the up row, you will get this my neural network function.
Sorry, Doctor, can you go back to the step, or can you copy and paste the predict?
This one,
Yeah.
prediction. Okay, I am doing that. Okay, just take this one, copy paste in your this file, ANN copy file. After copy paste, click on the run. After you run,
Is
come
PRDL or PRD1?
PRED1, any name you can give. It's
Oh,
like
okay,
predict.
okay, okay.
You know, we are making a prediction on some hypothetical thing.
When I click run, then this command change folder pop up from the.
Yeah, change folder. Then there will be a option of add to path. Just click add to path.
Sorry, click.
Add to path. PATH path.
Add to file. Which one is it?
No, when you run it, what it will give you, one will be change folder. Afterwards, there will be another box add to path, or you can do the change folder. No problem.
Okay.
Change folder. Go to after you did you get this PRED1 in your workspace? Everyone?
Yes.
Okay. Now go to your my neural network function. This file again. Click run. Those who have done add to path, they have to click run. Again, it will ask you to change folder. Change folder. Okay. After you did this, go to my neural network function. Click run. You will get the same error. After that, you see carefully now here. Take your cursor to command window. Select enter, then press up the button. There will be up and down buttons in your PC. Just click the up button. You can select my neural network function, and you are asking your neural network model to predict on the input given in grid 1. You are asking your ANN toolbox to predict for the hypothetical values which we gave in grid 1. So you just write my neural network function, uh, the bracket grid 1. Here it should not be a square bracket, it should be a common bracket. Just select grid 1, enter. The ANN toolbox will calculate and give you the result. What result we got? According to this ANN model, that will be negative 400. You know why? Because this ANN model is not fine. We had very huge error in the model development. Very huge error in the model development. So it cannot have the good accuracy. The accuracy is very bad. It is telling you about negative. So now the work is to make. First, we learned how to make ANN model. Now we have to learn how to make a good ANN model with good accuracy and good prediction capabilities, prediction power. So till now, you guys clear with this? So that I will now tell you how to make. First, it was how to make ANN model. Now I will tell you how to enhance the prediction capabilities of ANN models. Any question till now you have? Okay, after I type grid 1, I run the M5. No, after you type grid 1, copy paste here, grid 1, just run it. It will show here. Go to my neural network tool function again. After this, go to your command window. Here is your command window. Go to your command window, up button, my neural network function, bracket, write grid 1, and then enter. Is everyone got till here? I'm opening my video. I'm opening. I want you guys to open your videos if you have anything, because if you learn till here, now only matter is how to make it good. Okay, it's okay, Wilson, because see, everybody has one thing is your answer might change. Yes, definitely, no problem. Where did you run I will tell you, Wilson, why your answer and my answer is different. Where did you run this, Mr. V? Okay, Mukri's is same as mine. Okay, yes. Uh, we maybe I retrain. Yeah, you retrain. That's why your answer is different. When you call my neural network, yes, you click on my neural network. Go to your command window. Go to your command window. Press the up button. You will get this my neural network function. You can see in my screen, my neural network function. Write a bracket here, write the grid 1, and then press enter button. Press enter button. Once you press enter button, you'll get the answer. Okay. So we will spend 15 minutes time to uh, understand only the procedure to develop the NN model, because I don't want you to now we are once you know this procedure how to use the ANN toolbox. Now the matter will be only to make your ANN model with good prediction capabilities. That's it. There'll be no change, like in the procedure. Procedure will be same, only will be the optimization of the ANN prediction capability. So till now, what you have learned is basically how to make a ANN model. Now we are going to how to optimize it, make a best prediction capability ANN model. I ask you to make a Word file. You remember this Word file. The purpose of this Word file is that first we will keep the same algorithm ML, change the neurons, and then see what will be the MSE and R square. These things will go in your methodology section of the paper. I shown you my paper. In that we did not optimize the algorithm because in that particular application, the first algorithm was working very fine, so we did not think of optimizing the algorithm. But here you can even optimize. So your paper will have the first table will be of this this algorithm, second table will be of second algorithm, third table will be of third algorithm. By different neurons, what is the MSE and the R square you have. So is any one of you has any question till now can ask me. Because now I am going to give you guys kind of hands-on with your own things.
Doctor,
Yes.
so when we close all the regression output, the R squared, so how can we get that pictures again without retraining the data?
No, the pictures you cannot get again. You can keep your ANN models. You cannot get the pictures again unless and until you save the pictures. Once you get the pictures, I shown you guys how to copy and keep in your Word, but you can save them as it is in MATLAB. How to save them? Just go to the edit section.
Copy figure.
No, no need. If you do the copy figure, you can copy in your Word, but you can keep them as it is in your MATLAB. Just go here in File, Save. If you click Save, it will be in the MATLAB figure format, regression figure. You can save this figure. Okay. I close this one. I close this one. I close this one. Again, still I can get my figure back. You can go here, open this regression figure. You just select this regression figure, open, the figure will come back. But if you don't save this figure here, don't save this figure, you cannot get back this figure. You can copy and keep in your Word, but if you save in MATLAB, you can get again in MATLAB again. You can do copy here from here. So both the ways you can do it.
So
Okay.
if we have closed it again, right? I mean if you want to reproduce something similar to the regression fit just now, so if I go back few steps up to the validation and test data.
Yes, that one I will tell you. I will tell you to how to get another figure, because you will change. You will get a different figure when you do change the retrain the algorithm. There are three possibilities. When you retrain the algorithm, this regression figure will change, or when you change the training algorithm itself, or when you change the number of of neurons. So we are going to do that thing again, like after this. Okay. So till now, you guys are clear, right, with your thing purpose. So I'm closing my. Okay. So now what we are going to do is we are going to repeat the same step. Neural net fitting. Open the toolbox. Go next. Select your input. Select your output. Click next. Select your this thing. Now, in the last time we kept the neurons as 5. In this case, we are going to keep neurons as 10 and then see what could be the change in mean square error and regression. Now keep the hidden neurons as 10. Next, keep the algorithm same. We will see the different algorithm in next, like after this we go from 5 to 25, then we'll go to another algorithm and see what its capability. So you keep the Levenberg Margaret LM algorithm and then click on train button. Okay. Now you can see it is better. The MSC is better. We can see the performance. The MSC in this case for 10 neurons is 8464. It is better than what we had MSC of 24,343. So now we have the MSC of 8434. So just write it in your paper. 8434 is the MSC for 10 neurons. And what is the R square? You can get the regression here. The R square is 0.9996. So just copy here 0.996. Okay. After that, after you, if you want to keep these figures, you can go to file, save this figure. But when you want to save this figure, try to make another folder. We made 5, you make now with 10 so that you can have the clear picture which figure belongs to which number of neurons. ML is the training algorithm. Keep here MSC figure, save, you can save or you can copy and paste in your Word. Okay, after that, next, you will get another function here, my training algorithm. So once you click here, go to editor, now save this file. Because we change the neurons, we don't want this also to lose. So we will save this one in another folder, ML10 neurons. Save this ML10 neurons. Change. Now we want to see the prediction capability of ML10 neurons. Just run my neural network function because now this function will run, which we saved for 10 neurons, and it will predict. So it says the depths will be 6.08, so it will be 60836 when you have 20,000 confirmed cases. So still the model is not accurate because we have the MSC error is 8431. Can you guys able to do that for 10 neurons?
I still get the same 405. I don't know what went wrong.
What you got?
I mean, no, is the same value as the previous one. So I don't know whether the
Means you did not save your this after you make the 10, you did
or,
not
or
click on.
after retrain, then you have to press the same.
Yes, after you retrain, just you press the MATLAB matrix only function,
Okay.
code function. It will open here and save in
And save,
another folder.
save in the same folder or
No, save in another folder.
another folder?
Yeah, make another folder. I workshop. You can write. You can make ML10 neuron because it is ML is Manuel Lernberg algorithm name. 10 neuron is this thing. You can keep it here. So after you save, you run the file, you'll get the error, which was we got in the previous case because it does not have the input. Now you give the input, you will get the different answer. Is you guys able to get till here? I am seeing now the chat. I hope you guys have able to done. Can I share my screen? I done, but no results. Yes, you can share. I will stop sharing my screen. Okay, you can share the screen. Anybody who wants to?
Dr. Lal will share.
Yes. Okay. This okay. This screen you got after for 10. Can you okay? This is already saved. COVID-19 day 3. Okay, go to run. Go, click on the editor. Click on the editor.
Uh,
There is editor here in your
sorry.
above scroll.
Editor,
Yes, click
yes.
on the
Okay, editor, then
run.
run, right?
Yeah,
Run.
run.
Which one? The run, no?
Yeah,
Yeah, run.
yes. Now go to the command window.
Go to the command window.
Down.
Okay, yes.
Yes. Okay. Once press the up button.
Up button.
Yes. Okay. Go up.
This one?
Yeah. Uh, okay. You take this one only. Now you open a bracket.
Oh, okay. PR,
Write the 3 1.
right? Okay,
Enter.
type the pre and
Yeah. Enter. Yes.
is that correct?
Yeah. You will get answer. You got
Okay.
answer. But the thing is, you see now your I can see your current folder. It is very messed up. Uh,
Sorry.
because
Uh-huh.
why it is thing is if you're writing a paper
Uh-huh.
when you to reuse this algorithm for 5 neurons, 10 neurons, 15 neurons, you cannot use it because each time you are saving the same folder when you are changing, even you are changing the algorithms or anything, you are unable to do it. So I suggest you to make a different folder whenever you make any change in your toolbox.
Okay.
First time train for 5, 10, 15, so that this I'm saying in purpose for your paper writing. I'm keeping in mind that now you
Okay.
guys
How should I go? How should I go?
you can do that. I want you to open your MATLAB toolbox, that ANN toolbox.
This one, right?
Yes,
Okay, then
yes.
you mean the
Neural net
neuro?
fitting. Yeah, neural
Okay.
net fitting.
Uh-huh.
Okay.
So just now I used 5, right? Okay.
Yeah.
So I use
Let it open.
so I changed to 10, is it okay?
Yeah, you have to change to 10 now.
Okay, then what should
Once you
I
get
do?
code
Then
generation,
wait.
yeah,
Next, right? Next. Okay. Then is it the same
code
method or
generation. No, code generation, yes. Learnberg. Use the same.
station? You want
No.
to
Keep
the same?
Levenberg. Yes.
Okay, and then
Train. Next.
okay,
After train,
train. Okay, then
yes. Next.
just click next, huh?
Yeah.
But it's okay.
Okay.
No, it's not moving, right? Then
I'm unable to see that toolbox window.
can you see?
No.
Can you see the? Can you see my screen?
Yes, yes, we can see
But
the 17 iteration right now.
No. I'm not able to see your toolbox. This is the training performance.
this is a train network, right?
Yeah. After that, you press next. You get the code generation. Go to
Oh,
the toolbox.
you mean the 25 iteration, 26 iteration, right?
No, not this one. There will be another. If you click on your MATLAB
Uh,
down, be another MATLAB
okay.
toolbox.
Okay,
Yeah, open.
you just finished the training. So I go to next now.
Yeah.
Okay, you can see, right? Then
Uh,
next
code
again.
gen. Yes, you
No,
got code generation.
now I go to MATLAB matrix, right? Can you see the screen?
Yes. Okay, you got this one right. So
Okay.
now you go to editor.
Okay.
Go to editor. Run.
Run. Okay. Oh,
Uh, yeah. So now what you have to do
okay.
is
So I need
you
to save this one, right? But
yeah you save on different folder. So you can go to desktop
how?
or
Uh, sorry. How should I go about it? How to save in a different folder?
yeah, here you can see you move your cursor towards your left. You can
Left.
see desktop documents anywhere.
Okay. So I
Or
go
yeah, you click desktop.
desktop. Okay. Okay.
Yeah, you will
Desktop.
get here. Yeah, you will get your different folders here. But which COVID-19 second workshop, you can choose any folder you
This is the
want.
one I saved the
Okay,
any
so
folder.
open this
Do I
folder.
save
Open
one?
this folder.
Okay.
Now you click on new folder. You take your cursor here.
Left or right? Sorry, I'm me.
Little bit of left. Little bit of left. Yeah. No, just keep here. Keep your cursor. Move here and keep in the open space. How you open a new folder usually?
Normally I create first before I come in.
Okay. Now no. Just move your cursor little bit upward.
Uh,
Before this
Upward.
my
Okay.
yeah, little bit more. Little bit more.
Go.
Okay, now you click the right click.
Oh, okay. Okay. So new
Yeah, new
folder.
folder.
Okay.
Yes.
So I just
Now you write ML10 neurons so that you will know, okay, this algorithm is from ML
oh,
and 10 neurons.
so I save
Now,
inside.
yes, now you select that folder,
So I
save.
save inside here, right?
Yes,
Okay.
save.
Okay.
Once you saved, change folder.
Change folder.
Yeah. Come,
Okay.
come back to your command window.
Okay. I'm back here.
Yeah. Now you just write your up button.
I'm in command
But
window. What should I do?
yeah, in command window there will be a up button in your keyboard, up
Oh,
and down button.
yeah. Okay.
Yeah, so up button just select read one. Yeah,
This one, right?
yes, select and press enter.
Then enter, right?
Yes. Okay. Yeah.
Okay. So this is for
So
the 10 neuron.
yes, this is for the 10 neurons. So like this you have to do
Oh,
uh, because whenever we write a paper,
yes.
they don't accept only on one particular neuron, one particular algorithm. The reviewers or the editor will ask you, did you optimize your ANN toolbox? Do you think this is the best algorithm for this particular data set? So you have to give evidence in the form of tables or in the form of
Oh, okay. Sure. Oh, okay. So it has
okay.
nothing to do. It has nothing to do with the first. It has nothing to do with this file anymore, right?
Yeah, this file is just you have created your input output and one case for your prediction.
Oh, okay. This one I have to write before I go to changing the neuron. Yes, I need to put this before I go to changing the neuron.
change in the neuron, no need to do this one. Now this is already there in your workspace.
Oh, because the problem now, just now
Okay, now you go to
just
your,
after you type the predict, I need to run, right? I need to run, right?
no
But
need, no
because
need,
of
no
that,
need,
no need.
no need. It's
Oh,
already there in your workspace. No need.
oh, okay. Oh, so after,
Just go to app. After
oh,
this,
uh-huh.
close this my neural network function.
Okay. Oh, after this, go to the next one. Just now, like what I do again.
Yeah, just you close this one. There is a close mark here. Now,
Oh,
yeah,
okay. My question: are we predicting this one, or we predict this
we are predicting.
one based on the different neuron?
Yeah, we are predicting.
Yeah.
Yes, we are predicting the number of death
Based on different neuron.
based on different neuron for these input variables. The first input variable is the confirmed cases here is 20,000.
Oh, okay, okay, okay. I know.
Percentage population is 25% more. 25% of the population is more than 65 years age.
Oh, okay, okay.
50% population smokes. So in this is our hypothetical values,
Oh, I see.
and we are predicting the number of death.
Yeah, yeah. Okay, okay. Yeah, I understand. Okay, thanks, thanks. Okay, so I stopped
Okay.
sharing the screen. Thank you, thank you.
Yes.
Thanks.
Okay. Now. Okay, is the evaluate network before code generation? Do I change the input to an in output to, or no changes? No changes is required. Keep as same before. Okay, MSC results is based on validation, not forecasting. Does that mean that our prediction error is subject to validation error? See, the program, the MSC error is based on validation and training, testing. So whatever error you are getting, because it is from the same data set, randomly taken points for the testing and validation, so it should be less. And here we are not talking about forecasting yet. It is only about your validation, testing, and training. The forecasting will be done for once you run your code and you got your one value. That time you will get the thing. Okay, now what I want you to do is, all of you guys, uh, take second algorithm in your ANN toolbox. Now we did with the, can I share my screen? Just a second. Okay. Okay. Now instead of Leavenworth Margaret, take Bayesian regularization and make one algorithm for 5, 10, 15, 20, and write a table here, same like this, with Bayesian regularization, Bayesian BR. The algorithm, training algorithm will be BR. Calculate the MSE value and R square value for different neurons, 5, 10, 15, and 20, and then make this table and report, keep whatever MSE value you got, what the R square value you got for Bayesian regularization. I'll give you 15 minutes, and you have to save all the 4 files in 4 different folders so
So
that we can.
the R value is from which because we got like 4 tables with R value, right?
This all R
All
value.
R.
In this
Okay.
figure, yeah, all R value. So I want you to make this table. Once you are done with this table, I will tell you about different aspects of ANN model. So I'm giving everyone 15 minutes to go forward, backward, for 5, 10, 15, 20. But the training algorithm should be Bayesian, not ML. BR. Now we are changing the training algorithm to Bayesian. Okay, BR we are taking. So I'm giving you 15 minutes. I'm just seeing the chat. If anyone having the problem, Bayesian for 5, 10, 15, 20. Yes. Yeah, all. I just want you to get, yes, it is same as R square. I just want you to get used to this toolbox. and then you know how to predict the future value, future any assumption values you want. You can now predict how to predict. So I just want you to get used to this toolbox and see, keep the codes and all those things. So just 15 minutes. Let us see, you can do it for Bayesian regularization. And maybe if you finish with the Bayesian regularization, those who are doing very fast, they can also use for scale conjugate gradient, the third algorithm. We have 15 minutes time. I'll be back in 2 minutes. So anything, just leave a message in chat. I'll be come back in 2 minutes.
Dr. Irfan, are you there?
Okay. Did you guys able to do that? I think still not 15 minutes over, so take another 5 to 7 minutes time.
How do you open once we save the image, right? The feed, the regression.
Did you save or copy?
No, I mean I save as in the folder of the command line, right?
Okay.
And then when I
Okay.
double
If
click, then it open another MATLAB program.
it will.
uh, I don't know. It's because I got two MATLAB version in my PC. One is 2015, the other one 2018.
Okay. Okay. Okay.
So
If you
I don't know,
want to
maybe by
open this.
default it's set to 2015. So when I double click the image
Okay.
file,
No.
so it open another MATLAB 2015, not
Okay.
2018.
I will. I will share. I'm sharing my screen. How to open. Once you save the figure, just go home. Uh, Here, open. You can see here in the folder, or you can click the open. Here you can see the file which you have
Okay,
saved.
okay.
So just select the file and click on the open. So the figure will be open.
Thank you. So the feed value, right? The
Yes.
MAC value, right? So
Yeah.
that one, once we finish, when you click train, then you have this one box, the network training, right?
Yes. This
The one
box.
that shows you the iteration, the performance
Yes.
with but once the
Yes.
training is done, then this box will disappear, right?
This box. No. This box will be there for until you close it, or if you close the toolbox, then it will disappear.
Okay, okay, okay.
So you can get these figures, fit, error histogram, training states, trip performance. You can get this state.
Hello,
Yes, yes,
is the Bayesian, the iteration is set as 1000, right? It's, it takes some time to run it, right? To 1000. It
yes.
cannot be less than that, 500 or
The iteration, no.
Okay.
When you take the Bayesian thing,
Uh,
the iterations will be like based on your, you can see here, for me, it is epoch in progress.
uh,
Here is only 100 iterations. So it is like achieving the minimum error and minimum MSC possible. So if it achieved and it got saturated, what I can say, it is like saturation, like the performance cannot be improved further, then the iteration will stop.
oh,
So in
okay.
this case, it got stopped at 100 iterations.
What?
Or uh,
Okay.
so in Bayesian, like it will automatically do itself and find out what is the iterations it is required for your particular data set.
What normally
And
you put? Sorry, sorry to interrupt. You put 1,000, you will have to run until 1,000, and then you will stop, right? Correct.
we are not putting iterations. Oh, you are talking about hidden neurons?
I'm talking about the epoch also, but the number 1,000 is there, right?
Yeah, it will, the MATLAB itself will take from 0 to 1,000.
Somewhere.
If you have to change this one
Ah,
iterations, then you cannot use toolbox. You have to use NF tool in the coding.
oh, okay.
You know, here, if you use some toolbox, the toolbox come with some three assumptions or like, three restrictions. So you can do that. You can use NF tool, train LM function, and all those things, but it will be not so smooth here with the toolbox. You have to make your M file, and then in that M file you have to recall your MF tool, recall your function. Then you have to change these things there, but
Oh,
not in the toolbox.
oh, okay. Okay.
Usual cases, because we are not going to claim we develop a different ANN algorithm. This is for the guys who are working with the ANN research. Like we are just utilizing ANN for our particular field of research. So for us, no need to look for this thing into that much detail. We are just taking whatever is already developed by ANN researchers or the computer scientists.
So this ANN training is the basic, is the most basic ANN, is it?
This is not most basics. You can say this is it is like the advanced version of ANN, but MATLAB has made it very simple for you.
Mhm.
That's it. Instead of writing lines by code for everything,
Okay.
the MATLAB has made it simple.
So once we do, like, I mean, because I just finished the BL algorithm for, I mean, we had the MSE, R, and neurons, right? So at the end of the
Yes.
day, when we have, because all the R square is pretty high, almost one, right? 0.999 something.
Yeah, not necessary. It is not necessary for all data set R square should be high.
Okay.
Uh, there are few cases where I even got R square as 0.7.
Okay. So
So it is not necessary.
the main purpose, so when you change the neuron from 5, the hidden from 5 to 10, 10 to 15, so the main purpose is to determine which one that has the highest R square, is it?
Highest R square and lowest MSC.
So you want to minimize the MSE and increase the R square.
Yes, that's the main purpose of this.
So the how many neurons should you choose? I mean, is it depend on the size of your data? Like in this case, you start with 5 and then you increase with
It
10.
it depends on size of the data, and it depends on the correlation of each input variables with the output.
When you say correlation, so how, so do we need to check that before we run ANN, like we do a simple correlation matrix?
Usually what we do is like it is not possible, to do correlation. That's again that statistical analysis will come into another part, another domain. So what we do is we usually take 5 neurons initially. If you have, let us say, 100 data points, then keep on increasing to take a gap of 5 or 10, and then see, like maybe initially our MSE will be very high, but if you keep on increasing the neurons, MSE will become low. But at a certain point of time, let us say if your MSE is for 30 neurons is less, 15. But when you make the 40 neurons, it will increase again. So you will understand, okay, for this particular data set, my neurons will be around 20 to 40. So you will just keep playing in that to get the maximum. So
This is
that's
something
why,
similar to like in econometric, you have this AIC, BIC criterion, is it? The Schwartz.
uh, I don't know about econometrics.
Okay. Because one of the, I mean, simple tools to decide whether, I mean, that one is just to select how many length, you know, how many, if your data, let's say you are dealing with the time series data, monthly or quarterly, so you want to decide
Okay.
how many you know, like how many period that you want to use your data, like one period before or two period before, so one leg or two leg. So you have a certain criterion that we want to select value that minimize the criterion. So in the case of ANN, you know, it's similar to like the AIC, BIC. I mean, for
Yeah. In case of ANN, we are just want to minimize the error in the prediction. We want to have highest prediction capable model. So that's the purpose, right? So that case, we have to do this because there is no other way. There is no mathematical formula to calculate the number of neurons required for each data set. This is like trial and error. You have to do trial and error and then make your finalized one.
so what? So when we do so once we generate the equation, right? I mean, generate the function,
Yes.
and then we click run, and then
You once you
and then you go you uh, press the up button, and then you predict. So you got one value for different value for different neurons value for different neuron, right? 5,
yeah,
10. So what does this value means?
it
You know, like,
says that your different ANN model has different prediction capabilities. Whenever you change the neurons, the prediction will change. The prediction capability of ANN model will change. That also you can see that thing in MSE. Whenever you change the neurons, the mean square error is changing.
so in this case, for example, I got 6.5866 E plus 04, right? I mean,
Yeah.
can I just share my screen? So
Yes, I will stop my share. Yes.
where is it? So are you seeing my screen now? Or
Um,
your my what is happening?
Excuse me,
I'm
Dr. Ivan, can
unable.
I just jump in a little quick?
Yeah, yes. Go ahead.
Okay. So I get that if we run different neurons, usually we
Yes.
will get different numbers, right? Different R square,
Yes.
different MST. But I right now I just run like 3 times of neuron 15, but I get different number for every time. Is that possible?
Okay, you did retrain?
No, I didn't do the retrain. I just go
Yes,
back and then
it is
I set the
it
new
is
number.
possible. It is
Oh,
possible.
okay.
You know why?
Mm-hmm.
Because the division of the data points the MATLAB is making,
Mm-hmm.
and, the 70 for training, 15 for validation, 15 for this, is random, based on random numbers.
I
So
see.
if you take training might, the data points which were there in training may go to testing or may go to validation. So because each time it is random numbers which are going to pick 70 data points from the data set. So the training data points might change. So the accuracy will change. The modern capabilities will change.
Oh, so basically what you're saying is we usually won't get the same number every time we run the same number of
Yes,
neurons.
that's why. Yes, that's why
Okay.
once you run, you save your model and code so that you cannot retrieve the same thing again.
Okay. Got
So
it.
that's why you are saying saving the M file, like it is making a code for you and you are saving it so that you can just utilize that file, because you cannot get the same kind of answer second time when you.
And another question, we only save the metrics only function when we want to do the prediction, right? I mean, if let's say if you when you ask us to do the table, I mean we don't have
Yes,
to save the functions every time we run every different neuron.
yes,
Okay.
yes. It is not necessary to save the function, because when you get the best case, which is having the least MSE and the best R square, that thing you can save, because that is the function which is going to predict for you. That is the optimized neural network model which you are going to utilize for your prediction for anything.
Okay, sounds good. Thank you, doctor.
Yeah. Okay. One thing I want to, uh, Dr. Mukhlis, can you stop sharing the screen
Uh, I'm
for
a
a
bit
second?
blur right now. How to stop sharing the screen? So
Okay.
okay.
I just want to share with you the number of articles got published on this particular toolbox. You just go to Google Scholar, write ANN MATLAB toolbox. These are the articles which got published using a dynamic graph matrix, using a detection of classification of faults, six-phase transmission line using ANN, optimization of wind power generation prediction using ANN. So everybody has utilized the same ANN toolbox which
Whoa.
you're working.
So
You know,
how old is this?
why I'm saying this is, some of the time what we get, the idea is like, okay, this looks very simple, so maybe the ANN might be very difficult, very heavy programming, very big headache, and this ANN may not go for usual. No, this what you are working is one of the finest ANN models utilized everywhere. So no doubt you can use the same algorithm on any data set which you are guys are working related to COVID, non-COVID. You can work, you can make your models, you know how to optimize your model, you know how to predict. When you make a ANN model, how to predict it. The purpose of ANN is to predict. So you know how to predict, how to utilize your ANN model to predict something. You can predict for single values, you can predict for multiple values, you can even predict for next 15 days. For example, if you're working in share market or something, you developed a ANN model, now you just gives the input for 15 different days, then it will give you prediction for 15 days. So this model is one of the finest ANN model, and most of the algorithms will be worked on either uh, Bayesian, Levenberg, or the conjugate. Even in if you go to R software, do the ANN, R will require very large steps of coding. It will ask you for each thing. It will ask you if you want to plot. It will ask you to code, write a command, this thing. So I feel in my because I have used R, I have used Python, I have used MATLAB. To a non-programming guy, this is the best option for a publication or for a even for a patent, because this is a well-established one. No computer scientist will have any argument based on this toolbox. Just take the toolbox, run it, optimize your toolbox. Okay, the two critical aspect will be how to optimize the ANN model and how to prove your data is good. Okay, now I think you guys have done with this thing, so we will discuss some new thing now.
Class,
If,
if I can
yes,
just discuss one thing. I think we have only 30 minutes left and we are yet to cover our main data set. So maybe for the time being, we can just leave our
this is the main data set.
I mean, like we can leave our questions at the end for last 5 or 10 minutes. And in the meantime, we can cover the like whole data set of the things. And for the class, actually, regarding taking the questions, that's a suggestion.
Yeah, I agree. Can I ask a quick questions here? Sometimes when I run, right, when you say that put in when you push the up button and then you call the my neural network function and then I type in
Yes.
bracket, do I run first without the bracket and then I run with the bracket? Because when I run with the bracket, sometimes, I don't know, sometimes it gives me undefined function or variable PRED1.
Okay.
Sometimes when I run, it gives me undefined function.
Yeah, when you close this function, when you save the file into a different folder, whenever you generate, you make a file, you save it. Once you run this my neural network function, then only you can use it in command window.
Okay, so then only, so once I save it in the new folder, right?
Yes.
And then I don't run it, right? Do I rerun it again?
No. When you are pressing for run, that time only it is asking you to save, right?
Okay, so that's done. And then, so now I push the up button.
Yes.
Right? And then I put in bracket PRED1, isn't it?
Yeah.
But yeah, so I was just curious, like sometimes it works, sometimes it gives me undefined variable.
Okay.
Is it because of the path?
Yeah, maybe you no, once the period one is there in your workspace, no problem for the path. That's okay, no problem. But I don't know why you are getting undefined function, whether it is your manual network function is not getting saved or run, or that's the only possible thing. Because your period one is there in workspace, no problem. It is there in MATLAB memory.
Yeah, but then when I run my last question here, but then when I run my neural network function, right, and then I save it, the values in everything in the workspace, like, do I run again the predict one? Do I run again that PRED1?
You have to run again my neural network function in command window. Get grade 1. That's
it. So I run that one before I run my neural network function in bracket predict one, is it?
Yes. Yeah.
Okay, I see. Okay, thanks. Another question, sorry. But then if you say that this one is like just now the earlier question, he said that he kept on getting the different numbers, right? So if he goes back and then get different numbers, so that means the solutions is not really quite stable, right?
Solution, it is not solution. It is like for each thing, ANN works with the random number theory. So whenever each training set, the training values, training observations, validation observation, and testing observations are different.
Okay, so that means the number keep on changing. That means from the predict, the input that we have, the predict values that we put in, that means the confirmed death is not certain, right?
No. Confirm that is you will get different for different ANN model. Confirm that you for different ANN model. You have to decide which ANN model is first. For that thing, I have asked you to change different neurons and different algorithms.
Oh, okay.
Okay.
Thanks.
One thing is when you see the Excel data sheet which we are working now. Here, one problem with this data set is for few days, like for few countries, the confirmed case is 0. For example, when you see the first observations for Italy, on 1st of January, there is no confirmed case in Italy. And that's why there is no confirmed death in Italy. And it is 0, and then it is changing from 0 to 3, and then it is keep on changing. So this is the reason why we have the less accuracy in the ANN model. We are getting large value of MSEs. So how to do this thing, how to overcome this thing is the first and the easiest solution is to take the countries where they have reported their first death, the data from the country when they have reported their first death, just take that data for training. So this is like data uncertainty analysis of your data, like how good is your data and how reliable is your data, because ANN is all based on your data. So I purposely did not go directly to first death. I kept it as it is, the data which I have got as 0 and the 0. So now, even in your case, you guys are working, you guys can easily remove this thing in the Excel sheet, just delete those columns where until the first death is not reported in that particular country. After you do that, you retrain, you import the same values in the editor, give the same inputs, give the same output, only the values will be different, and then try to train the algorithm and then use the prediction. Okay, one thing is that. The second thing is, now we have know how to predict. I have given you grid 1. This is like one scenario. In life, we don't have always one scenarios. Like we have, most of the time we have, we want to predict for 10 different scenarios or 20 different scenarios. So in that time, how we are going to do that? Just a second, my MATLAB got disconnected. Okay. Yeah. So now we want to predict for 2 scenarios or 5 scenarios. So I've just taken 2 scenarios here. Like in the first scenario, This is like when the confirmed cases might be 20,000, or in another case, it can be 25,000. And then the age, which has the 65% population in one country, let us say it is 25% population, in another country can be 50. So like this, you can give the different future prediction scenarios in each rows. You can give 2 values here, you can give 5 values here, you can give 10 values here, and then just right here, run whichever is the best ANN model you have calculated, use it. It will give you the death for each scenario. Like it will be the first one is for first 20,000 one, second one is for 25,000 confirmed cases. Any thing else you guys have? I think Dr. Ashraf, I did not understood what's the main data set you're talking about.
Dr. Ipam, what I mean actually, right, in the prediction model, right,
Yes.
we have multiple countries, right?
Yes.
For example, the confirmed cases in one country 2,000, another country 3,000, another country 4,000. How we
Yes.
predict all the countries at the same time? Values.
That's what I showed now.
Yeah, that's what I'm telling you. So for those values, how we input in this modeling? Because now we've done the modeling, but for exact value, how do you put? That was what I meant.
You can give the exact values. For example, here you can have another Excel sheet. You have the confirmed cases. Just write the names here, the variables.
Okay.
I can give, for example, I can give the same names here.
Okay.
But you can give a different one. Like you develop a model for Italy, France, and now you want to use for Germany. So just give confirmed cases in Germany, India, Malaysia, and Pakistan. Just write it here. Give the confirmed cases here for actual values.
Okay.
Once you are done, this thing, just give it here.
Then it will calculate for all the countries, right? That's listed.
It will calculate for all the countries.
Okay. And the values will be given is like aggregated value or separate for each countries.
You can give, you can give the aggregated one Excel sheet.
Okay.
You can give separate. For example, I give the same values, repeated values. Okay. Now I want it to predict. It will predict. It will give you the A for each scenario. What will be the rate?
So each scenario means like if we have the asthma patient, this percentage, or people more than 65, this percentage, then it will be the value. Is it?
Okay. Now, let us say I will give you one example. Just tell me about the confirmed cases in Malaysia, around 5,200. Okay. Now we get 5,200 confirmed cases in Malaysia. And we have the age population, 25%, let us say 65,000. But here, instead of you don't want to write only Malaysia, you want to calculate also Malaysia and Indonesia. So confirmed cases in Indonesia is 8,000. So just write comma 8,000. You also want to predict Malaysia, Indonesia, and Pakistan. Confirmed cases is 11,000. Just write here 11,000. Okay. This one is like manually you are giving input for each variable. Otherwise, you can just take, if you have an Excel sheet where you have the confirmed cases from Indonesia, Malaysia, Pakistan, India, just bring the Excel sheet here, give them different names to the workspace, just copy paste that Excel sheet. Only thing you have to consider is the first variable, the input variable is confirmed cases. So your first input variable should be confirmed cases.
Okay.
The second input variable, the age of the population more than 65%, yours should be more than 65%.
Okay.
Is if you mismatch the input variables, the model will not it will give you some funny numbers, something which you are unrealistic thing.
Okay.
So only thing you have to consider is what input you have taken here. The first input is confirmed cases, so you have to always give confirmed cases. The first
And
input.
rest of the variables could change, right?
Rest of the variables could change.
Okay.
No, not rest of the variables. Like the values can be changed,
Okay.
but that particular variable should be at that particular spot. If my third variable is percentage smoker, so whenever I am predicting, my third variable should be percentage smoker. Whatever value could be. Maybe it may be 0, maybe it may be 100% population is smoking, but the third variable when I am predicting should be percentage smoker.
For example, Dr. Irfan, now we are using the data set, the IFintel COVID-19, right? And we have this
Yes.
column number, confirmed cases, 65% smoker from that IFintel COVID-19 data set. So
Yes.
our input variable according to that, our output variable also according to that. But the prediction, the number we are typing manually. So, but instead of typing manually, we just put the variable name. So it will take all the countries value, right?
Yes, first thing what you have to do is you have to bring the all the countries values to the workspace. Like if okay, I think is there any sheet has this, because I merged this one from two sheets. I
Okay.
don't any sheets has these two things.
I think all the confirmed cases, they have the multiple countries, right? Every variable.
Yeah, multiple. Yes, you can give multiple countries.
Mhm.
Just give me some time. Okay, because this is the data set from Oxford data. Okay, I'm creating, give me 5 minutes time. I'm creating I will show you that one using a Excel data set.
Okay. Because most of the time, actually, like we have a ready data set, we don't type it manually. So how
Yeah,
just
yeah.
yeah.
I'll just show you that one.
Okay.
Uh,
Ngantuk ah.
okay. Can you able to see my Excel sheet?
Yes, we can see that.
Okay, sorry. Okay, you can see now. So now we created the model for Italy, Spain, US. So now let us say we have the data for India and Malaysia, and we want to predict what could be the confirmed death for all these possible scenarios.
Okay.
Okay. Like other parameters, I did not change the population age. I just kept it for as Italy, but I can change because I have to copy from another data file. So I just kept it this one same. So what you have to do is once you generated the file, uh, go to app, home, import data. Now you are importing the data for COVID-19. Sheet 3. We are importing now this data, India and Malaysia's data.
Okay.
So just import as column vectors, import it. So now it has created another variable here. The first is confirm case. This is confirm case 1, which we just recently imported. Or you can give another variable name if you want. But what we can do is we can just give this one okay. Now we are giving confirm case 1. So it will be India and
Malaysia.
Malaysia. Yeah, smoker 1, high blood pressure 1, daily asthma 1. So 1 is for like which we have just imported.
Okay.
2018 one. You can see here right in my workspace,
Yep.
it has created 2, smoker, percent smoker 1. So this 214 values is from this particular data set. This has 214, India and Malaysia. You see 214, the first, if you remove the first row, that is
Okay.
the. So we have just given this input. We ask, okay, work on now, work on India and Malaysia's data. We defined it as trade 1 as the variable. We code, okay, age 65, age 1, okay. So population, okay, population 2018, it has become as population 1 now, new variable. Okay, physicians, people 1. Okay, so now it has taken the data from India and Malaysia. Now we are just calling the ANN model, whichever is the best one which we develop, and asking to work on this India and Malaysia's data set.
Okay.
So you can also give your output name.
Mhm.
Yeah, and Malaysia that as my neural network, and just use this data set
Okay.
and press enter, it will give you. It will also save here in workspace India and Malaysia that which we just defined. This is the confirmed death cases for India and Malaysia. The first
Doctor, sorry.
is,
The things that I want to understand from here that we have 1, 2, 3, 4, 5, 6, 7, and 9, 10, 11.
yes,
Different 17.8008. So what is
yes.
the difference between from column 1 to column 11? What does that indicate actually?
Actually, this column 1 to column 2 is when there is 0 cases,
Okay.
confirmed cases, because it is 0. The death rate got trained not only because of the confirmed cases, and the model is not only working on the confirmed cases, it is also taking other parameters, right?
Yeah. Yes.
So it says even if it is 0 confirmed case, there can be 17.8 deaths. So that's why I told some time back that we have to remove that 0 cases in the data.
Okay.
Here you can see as the values are increasing, when the confirmed cases is increasing in the data file in the Excel sheet.
Okay.
This is the Excel sheet, and when the confirmed cases, for example, at the 100 value,
Okay.
at the 100 value, you can see the confirmed cases in India is 5194 and there is 149. The ANN can say at the 100 value, uh, 101. According to this ANN model, at the 100 value, the confirmed death will be 274.
Okay.
You understood?
Yeah.
So you can give all countries together, or you can just give India's data and get the death rate. And then what you can do is you can just copy this whole variable,
Mm-hmm.
copy from here, just select copy, and you can paste it here and then do the comparison between predicted and the developed thing.
This is the compiled value for India and Malaysia together, is it?
Yes, because the data which we gave is combined. We did not distinguish the data. So
Okay.
that's why I'm giving you the combined. But if you want, you can just give the input data as only India, only Malaysia, separately country-wise, or you can just combine all together, the whole world you can give.
And that will give us the value like, okay, if there's the predicted death rate and this is the what happens. But if you want to forecast, how does it work?
How do you forecast something?
Yeah, I mean, like it's like until 22nd of April is like that. So how
Yes.
to happen next time?
For example, if you want to forecast, the basic forecasting is done based on, you will have some assumptions. Here we are not working with time. The date doesn't matter. For example, you have today is 5,000 confirmed cases. You are forecasting in number of cases. Like when Malaysia reached 7,000 confirmed cases, what could be the death?
Exactly.
Yeah, just go here. You have trained the model. Just change confirmed cases. Make it here as 7,000. Keep everything same.
Well,
You understood?
Yep.
Now hypothetical, you have same confirmed cases. You see, okay, my country's habit is not good in smoking. If my smoking was 5%, what could I would have made in that rate? Just keep everything else same. Change the percentage smoker here as 5%. Instead of 20, which was initial, if you keep 5, you can say, oh, see, if the Malaysians' habit was to smoke less, the death could have been reduced by this much percentage. That's how you forecast. Yeah.
Yep.
Do I need to?
I have a quick questions here. Like the one that we did just now, the predict, right? We put the initial predict value that we did before you introduce this thing, but we have a list of panel of countries, right? So when we just specify for one, that means by default it will take the first observation, is it? The Italy one, is it? You remember that earlier when we do our predict, right? We have only one observation, isn't it?
Yeah, not here specifying the observation.
Yeah, but what I'm saying is that now in this case we have the India and Malaysia, but the earlier case we have a set of countries, right?
Yes.
Yeah, in the set of countries, but when we do a prediction, we just put in one value.
Okay.
Right. Well, one reference only, right? So then it will take in our panel data set, it will take the first one. Is the prediction for the first country or the prediction all throughout?
No, if you give here any single value here in period 1, any value, it will not only take from Italy, because the model got trained from all the data set. It has taken, it knows how it affected in Italy, how it affected in US, how it's affected in here. So here you are giving a value of confirmed case. You're not taking the value from Italy, you are giving any values. You understood? Like this one will not take only Italy value. Now it doesn't differentiate between Italy, US, and everything. It takes all the data and it has developed itself. It understood that when the confirmed cases increase, the death rate increase, and what could be the other parameters plays a role. Like it will see in the some countries where the age population 65 is less, the death have reduced. So it will see that thing also into the correlation. Then it will take only that value.
Oh, okay. But just now we got one number, right? After we run our prediction, so we got one number. The answer is one. The
Yes,
one number.
that
So the
number
one,
is that one number is not based on Italy. That one number is based on a model trained for all those countries.
can we say that on average, this is the number of
Yes.
predicted confirmed cases? Oh, okay.
Yes, on the data set developed on that particular country's values. If you want to get only for Malaysia, then you have to develop your ANN model taking only Malaysia's data.
Or we can just put the Malaysia in the separate template that you showed just now.
Yeah.
And run only on Malaysia, right?
Yes, run only on Malaysia, develop only on Malaysia, and then use it.
Okay, thanks.
Can I interpret it like this, that for those particular countries, if the number of cases increase to like 5,000, then the number of death will be this.
Yes, that's what you can do it.
Five countries, just like these 5 countries aggregated number, if reach to the 5,000, then the death will be this.
Yes, for me, if I'm working on this particular paper,
Okay.
how I'm going to work is I'm not going to take all the countries because all the countries have many different parameters apart from this, case, death rate. So what I'm going to do is I'm going to just concentrate on Malaysia, for example. I'm just going to take Malaysia's data, train the ANN model on the Malaysia's data, develop the ANN model, and then after that, what I'm going to do is I'm going to find out the death rate at different confirmed cases. For example, when Malaysia is at 5,000, this is the death rate. When Malaysia goes for 7,000 confirmed cases, the death rate will be this much based on the ANN prediction. When Malaysia goes for 20,000 confirmed cases, the death rate will be this much based on the ANN prediction. That's how it will work.
That's for the time series data, right? Yep.
Yeah, that's how, that's the basic prediction with respect to COVID is there. But the problem here is when you talk about only Malaysia's data, here the data points will be around 200 and something. And you are predicting the data, and initial few values is 0, like where the confirmed cases is 0. In the Oxford data set, this is the main data set which I use for the finding the confirmed cases. Like this is the data set. You guys see this Excel sheet? Yes. So in this Excel sheet, you can see that initial at 1st January there was no case in Malaysia. The Malaysia's cases started at 26 January. So from 26 January, you have very less data points in this Excel sheet. For Malaysia, you have only around, you lost around 25 there. So 180 data points. So based on only 180 data points, it will be very difficult to get the prediction. My source of data this is the Oxford data set Dr. Mubin has shared with me. I think he got from some open source. I don't know exactly. Dr. Mubin is the source for me for this data set. Dr. Mubin, where did you got this Oxford data?
This data set actually is publicly available from Oxford Government Policy Tracker. Anyone can get it from there. And that's actually already ready format in the panel. But if you want to add some other variables, because they have only the policy tracker, confirmed death, and few others, then you need to compile with different sources.
Yeah, so For today's session, what I did was I used this Oxford data set for confirmed cases and that. Then I also utilize the data
Masuk juga abang tu
for
dalam
this
pun.
one file.
Bila abang nak tengah nak buka. Belum buka lagi, belum buka mic-nya. Ya.
This file, you guys can see here. This is for single variable for each like age, population with respect to each country. So I merged these two data set, like confirmed cases from Oxford data set and the other variables, age 65 years, asthma cases, percentage smoker from this data set. So I merged these two data set and make another data set. I'm clear now on how to predict.
Buka mari atas.
For me, it's clear. Rest of the participants, you can comment.
Buka atas.
Yeah, you
PTI
guys
tu,
can
ada atas
ask
PTI tu.
in the chat.
Ada bakul, ada bekas tu.
Any other thing you feel like you have missed or you've not understood or confusing thing, can ask me now. Otherwise,
We had opportunity to ask Dr. Irfan, so please take the opportunity to ask
yes. Even though maybe you guys today you have understood this MATLAB or working today, it is not like only for today, and you are working with some data set on the ANN toolbox, you are not having any, you feel any problem, you can email to Dr. Ashraf. He can contact me and we will try to solve your problem even after maybe after 1 week. Also, you have something, you feel free to reach us, and we hope that we can able to help you. If you're working on any of your paper or anything, you have any problem, you can feel free to reach us. Any other thing you want to ask me?
Dr. Irfan?
Yes.
Okay, so what we have done today is basically, I mean, the codes or the training is just to, I mean, when we have the R value, the MSE, that one is just to see the goodness of fit test, right? The how good the model is. But I mean, basically,
yes,
whenever I mean, I read an ANN paper, you want to compare between the actual data and the predicted data, right?
yeah, if you have in some cases you will have like for example you trained on one experimental data set and you have another experimental data set but you did not use for training, and that case you can use the actual because that is from experiment you got, and then you can use the ANN to predict using FID1, then you can do the comparison of both. But in some scenarios, like in COVID case, something is hypothetical where you don't know what could be the actual number. In that time, the model is accepted based on MSE and R square, which you got on the training, on the development, model development, what you got the MSE and R square. If you show them that you utilize all the three algorithms, you have done the optimization for the neurons, you have gone from a large range, and then you feel that this particular algorithm and this particular neurons are the best fit for this data set, and then you do a hypothetical prediction. Like for example, just now we discussed about Malaysia's case, like when the confirmed cases reach 7,000, 10,000, 15,000, 20,000, the death rates will be this. In that case, no need to do the comparison between the actual and the prediction. That is the based on the hypothetical which you got from the NN. That will be confirmed only when if that numbers reach in Malaysia or any other. But other case where you have the data, then you can do that. You can say we use the ANN to predict, and then also we compared with the available data for the that particular prediction, and then we find that the ANN works fine and the prediction is very close to our R-square is 1. It depends on how the data availability is.
Dapatkan dekat speaker tu.
Any other question?
Okay. Sorry, Dr. Irfan. Last question, I
Yes.
guess. So, basically, you know, now that we already know how to run the ANN.
Yes.
So, first thing first, you just have to, you know, run all the models, you know, using different neurons, different, you know, Bayesian, different
Yes. Different
all
training
those techniques,
algorithms.
right?
Yes. Yeah.
So basically, you run all three techniques and then run different neurons and then find the lowest MSE and highest R squared. And then from there,
Yes.
then you can start predicting.
Yes.
So when in the methodology section,